Hello everyone, welcome to codeandme.com. Today we are going to talk about an important concept in computer science, which is binary heap. So before we go on to explain what is binary heap, we should know about the following topics: binary trees and the type of trees. These are the prerequisite for learning binary heap. So okay, so before moving on to a binary heap, you should know what is a complete binary tree. A binary tree is a complete binary tree if all the labels should be completely filled except the last one, and all the leaves in the last label should be as left as possible. So what does this mean? So let's look at a complete binary tree. As you can see that in this binary tree, all the labels, level 1 is contains only one node, level 2 contains two nodes, level 3 contains four nodes, and similarly level 4 also contain fourth node, which is also the last level. As you can see, except the last level, all the levels are completely filled. So that was our first condition. The second condition is that all the leaves should in the last level should be as left as possible. This means that there should not be any gap between the nodes of the last level. So if you look at this example, you can see that 8 has a left child 7 and 8 does not have a right child. It was possible that 8 should have a right child. So this is a gap between 7 and 11. Similarly, 10 has a right child 11, but it doesn't contain a left child, uh, which could be anything. But what my point is that this left child should have existed for this tree to be a complete binary tree. So as you can see that there is a gap between 7 and 11. Thus we can say that 11 is not as left as possible because there is a space in the right child of 8 where 11 should be to be a complete binary tree. In this you can see that there is not any gap between 8 4 2 1 between the nodes of the last level. So thus we can safely assume that this is a complete binary tree. So once we have understood what is a complete binary tree, let's jump into directly into binary heap. So binary heap is a special type of data structure. Binary heap is said to be binary heap if it follows the following two conditions. It is a complete binary tree and all the nodes in the tree follows a property that they are greater than their children. So let me explain you a little bit. Basically, binary heaps are two types: a max heap and min heap. All the rules which are applicable to one type of binary heap are also applicable to the second type of heap as well. So we'll discuss majorly max heap in this video. You can see that this heap or this tree is a complete binary tree because all the labels are completely filled except the last one, and the last one also last one is partially filled, but it follows our second criteria that all the leaves are as left as possible. Now we can see that this heap contains this heap contains the root node 13 and the child of 13 are smaller than 13. As you can see, 13 has 11 and 7 which are smaller than 13, and similarly all the childs are smaller than their parents. As you can see that 11 has two childs 9 and 5 both less than 11. Similarly 9 contains 8 and 4 both less than 9. Similarly 7 contains 6 and 3 both less than 7. So you can see that this tree holds a special property for all the subtrees recursively, that their parent would always be greater than their child. So you can see that this this tree is a max heap. Similarly, for min heap, the condition reverses. So basically, the condition becomes that that um, all the parents are lesser than than their children. Okay, so let's look into an important representation of heap, which is array representation. So basically array heaps are represented in the form of arrays. So as you can see, this is a max heap, as it contains all the parents, as you can see, are greater than its children, and there is an empty array which is whose indexes are represented by these numbers. So we will represent this heap by this array. So first we'll put the root node at index 0. Next, we'll put the left child of the root node, which in this case is 11, at the next index. The next index is 1. Now, we'll put the right child, uh, we'll put this right child in the next index, which is 2, and so on. So basically what we are doing a level order traversal, or breadth first traversal, and we are just putting the value of nodes in this array. So you can see that 13, 11, 7, 9, 5, 6, 3, 8, 4, 2, 1. So as you can see that this array will contain all the nodes of the heap. And why we are doing this? So to understand this, we can take an example, because we know that this the index at the value at any point will contain, or in this case the value of root 13 will have a right child, left child, which is 11, and then 7. So we can see that each node has the parents of each node can be found out by a relation, some type of relation, uh, in this array. So if you will closely observe, you can see that if a root node is at index 0, the left child will be at index 1 and right child will be at index 2. Similarly, if this 11, if we talk about 11, you can see that its left child is 9 and 5, which is at index 3 and 4. So we can say that for index 1, its left child is 1 and 2. Similarly, 1 for index 1, the left child is 3 and index of 3 and 4. So if I have a node at index I, then I can say that its left child will be at 2 into 2 star I plus 1, and right child will be at 2 star I plus 2. You can put any value in this formula and you will see that it will hold this relation. Why it's holding this relation? Because heap is a complete binary tree. That's why we know that this this relation will hold true, because there won't be any gap in the array. So we have, for index I, we know how to find its left child and right child. Now we'll see how to find the parent if left child or right child is known. So we know that for index I, we can find the left child at 2 star I plus 1 and right child at 2 star I plus 2. S- So, by reversing this calculation, we can easily conclude that if an element is at n, then its parent can be found at floor of n minus 1 by 2. Why we are taking floor? Because this element n could be left child or right child, and in both the cases, if we take the floor, we will get the absolute value, the integer value for this element, or for the parent of this element. Okay, so in the next lecture, this is it for this lecture. In the next lecture, we'll talk an important function, heapify, which is a very important function in binary heap. So thank you for watching. Thank you.